started by Kulbir. So Kulbir will have about 15 minutes to just introduce CEMDI to everybody.
Thank you, Ken. Thank you so much, everyone, for being here. And it's really a great pleasure to have all the speakers here and among us today. And I'm Kulbir, and I'm a physicist by training, but I did chemistry, as I was talking with Josette in the morning. After that, I started doing chemistry. Now, if the chemist asks me a question, I say I'm a physicist. And if the physicist asks me a question, I say I'm a chemist. So I'm in a very nice area of research. Anyway, but I like to do computational simulations because they are very cool. So if we think about history of science, I'm sorry I'm not going to bore you with history, but it's really cool. We used to do everything with experiments, hit and trial methods, and we did a lot of discoveries using that. If we just think about a small molecule like hydrogen and how it interacts with any material, you can see the revolution that created. So way back in 1823, the Daubigner's lamp, how hydrogen interacted with platinum, that resulted in first flame or first commercialized application of heterogeneous catalysis. And today, if you guys, any of you live in Old Port, there was no electricity. And that discovery was super important. So because I worked with candles and the lamps in the morning at 5 a.m. today. So after that, Sabatier reaction is currently it's predicted to be about $66 million market in 2026. It's again hydrogen, how it will split heterolytically, homolytically, that decides the nature of this reaction. Hydrogenation of double bond. We wouldn't have our fats and oils unless we discovered hydrogenation. Haber-Bosch, again, it's a $110 billion market predicted to be in 2028. And here again, nitrogen interacts with hydrogen to produce ammonia. This is synthetically done, although it organically exists in nature, ammonia, but we ended up doing it synthetically because that was needed, and that brought the agriculture revolution in 1908. And again, Fischer-Tropsch is also currently about $7.9 or $8 billion market. So if we just think about this small molecule, how it interacts with matter, that has changed our past a lot. Now, not only that, not only hit and trial, experiments happened by accidents as well. Like all these discoveries were done by accidents. Now you will think, why I'm talking about experimental science in computational infrastructure seminar day. Let's go back to the theory. After that, physics laws came, Newton's laws, Maxwell's equation, they changed everything. We tried to understand chemistry, physics in a different way. And that helped a lot. We started solving equations. Schrodinger equations were used to calculate the energy of hydrogen, but then they grew too complicated, right? We couldn't solve energy of helium because it was just too complicated. So then people start simulating. That's where third paradigm came. And people start simulating, and that's when DFT, very well-known theory, got established. It took us for almost half a century, we were working with DFT, and we were simulating the equations, and we were coming to the conclusions, and so on. But then now, if we talk about now, experiments as well as theory, we generate a lot of data. There is enough data, there's so much data such that Jim Gray, he's a Turing Award winner in, I think, 2015. He once said that experimentalists don't look through the telescope anymore. They look through the computer, because telescopes are too complicated that they generate the data, and data is sent to the computer where they sit and look, right? So we have so much data. And what do we do with that? And that's where AI or artificial intelligence or data science comes into play, and is playing a very important role. And not just because we have a lot of data, we need to work with AI. It's because of many pressing issues, such as climate change. Climate change is simply change in energy imbalance, and due to which we see rising temperature, melting ice, extermination of species, and so on. And if you think about climate change, the first time greenhouse effect was discovered was in 1850. And British physicist John Tyndall, he's the first one to report that. And it took us almost a century to say that this greenhouse effect is actually responsible for climate change. And James Hansen, he predicted that in the coming century, we will see this climate change. We will see rising temperature. We will see extermination of species. Since then, since this after 1981, we have been trying to mitigate climate change. There are several discoveries: LEDs, solar cells, windmills, SOFCs, and so on. But we are not there yet, right? Our goals are right here, and we are not there yet. How to close that gap? And that's where computational analysis could be very helpful. And if you think about all these discoveries, advanced energy materials lie at their center. Whatever it is, photonics, photovoltaics, CO2 capture, catalysis, you name new technology that needs a new material or improved material or better material. How do we get to that point faster than our previous pace? Oops, I don't, okay. So that's where CEMDI also has the same goal. So our objective here is to accelerate the advanced energy material discoveries. And I think INRS is a perfect host for that, because here we have several groups who work together. Not only they don't just do experiments or theory, they do theory or computational analysis and experiments in the same group. So they have taken advantage of these both two streams very beautifully. Our objective is to train young students, of course, provide access to the computational infrastructure that we have. We have a great expertise here at INRS who in different techniques, different softwares, among different groups. So students have access to that. Our objective is to enable industry academic partnership. And the reason is all these discoveries in the past are driven by industry application or the technology development. So that's one of some of our goals. So we invite everyone to get in touch with us if we want to collaborate on something. You have if they're through collaborations, you can get access to all the infrastructure that we have. And of course, to attract young students towards this field, which could be really helpful in mitigating pressing issues like climate change. Now, I will go a little bit deeper about some of the topics that we work on here at INRS. So here there are some computational works that are done for, better thermoelectrics. We do, for example, in Professor Liang's group, we do image processing for overcoming the limitations of existing instrument. For example, image speeding, detection of sensitivities, etc. Then in Kent's group, we also do multi-scale simulations to investigate interaction of high-intensity short pulse laser with materials, which is very useful in case when we don't know the pathway to discover new materials. So that's where Professor Kenneth's group is working towards. Then we do numerical simulations for designing unprecedented materials, for example, multiferroics. There are several works on AI, quantum mechanics, classical mechanics. We use that to design catalyst for sustainable catalysis, CO2 capture, and so on. We also are working on automating defect detection in materials for fuel cell applications. And lastly, we are using electromagnetic design for exploiting plasmonic effects for photocatalysis. So this is just to touch the topics that we are working on. There are several other areas of research we are working on where AI, computational chemistry, physics, and numerical modeling are other techniques which are related to computational world are being used. So CEMDI was, I think it was last year when we established CEMDI. Currently, there are 10 PIs who are part of this consortium. And we also have several professors, students, postdocs, industry partners who are part of CEMDI. Since it's very new, we are trying to, we want to attract more students, more postdocs, collaborators from other universities globally, and of course in Quebec and Canada. So last year we hosted a seminar series where we hosted several speakers from different universities. We have one seminar every Thursday on second Thursday of each month. And we talk about computational material science. It's a very friendly environment where our presentations are shorter than the discussions. So our discussions go really long. And then we also, all these seminars are available for students and researchers who are interested in these topics on our YouTube channel. So our online audience is way more, specifically due to COVID. We are trying to bring more and more people to come interact in person, but we also have these videos available online so they can revisit the talks. And our next seminar series is going to be for closing the gap between industry and computational research. So we're going to invite a lot of industry professionals here who are going to be speaking about the implementation or the application of these techniques in industry. So of course, all the students and everybody are very welcome to join from other universities as well, or speak here as well. So today, we are here for the CEMDI Seminar Day, and again, I cannot be more thankful for all the speakers who came here for this day, and I'm looking forward to hearing your talks. We're going to have our next talks from 10 to 11. After that, we're going to have a photo downstairs. Just 10 minutes, maybe 5. So we will go downstairs in front of reception where the photo will happen. Then there is a coffee break for 10 minutes. I'm sorry, it's just 10 minutes because we had too many talks and we didn't have a lot of time for the coffee. After that, we will have talks from 10:20 to 1. At 1 to 2, we have lunch organized for the speakers, guest speakers, and CEMDI PIs only. Talks 2 to 3:20, and then another coffee break. And we will finish around 5. So this is the program of the day. And the talks and everybody, the list of the talks is given online, as was communicated earlier. Lastly, before, I don't want to do this in the end, but just a few seconds for the organizers. I have been so blessed to have Francois Ken alongside me to organize this. Jose Yeser, who are the superheroes of video making. They have no idea how to do that, so they are now doing that, and it's amazing to have them. Aida Rasool, they also helped in organization. They are the PhD students, so these PhD students are actually doing all the work. And center administration, Francois and Rufan and other members, and our INRS communication team. So lastly, thanks to all of you for being here once again. Thank you so much.